This is video number 2 on factoring, picking up right where we left off. This one looks a lot more challenging. Please copy this down. Let's factor. And the better way of looking at it is factor out the GCF, the greatest common factor. So you have 3 terms, 1, 2, 3. What could you pull out? Let's first start with the coefficients, 12, 6, and 2. What is the GCF that you could pull out right there? 2. So you have 2. And how about, are there J's in common?
Yes.
Yeah, there's a J here, 2 J's here, and 2 J's there. What's the greatest amount of J's that I could pull out?
1.
Only 1. Pull out 1. So we're going to pull out 1 J. And how many K's could I pull out?
1.
I can't pull out K squared and K squared?
No.
No, because right here is only K with 1. So when you look at all 3 of them, the greatest amount of K's you could pull out is just 1 K. So your GCF really is 2 JK. And I'm not just kidding. I'm really serious about that. Okay. So if I do pull out 2 JK, what's going to be left?
You want to record me?
Yeah, I am recording.
No mami.
6 what? 6K. Now again, the way to do this, think 2JK times what gets us 12JK squared. You're going to think 2 times 6 gets us 12. J times, you don't have to worry about it because there's only a J. K times K gets us K squared. So let's do it one at a time here. 2 times what gets you 6? And of course, it's going to be a positive 3. So let's put plus 3 right here. And then how about J's? J times what gets you J squared? J, okay? And last but not least, K times, I don't have to worry about it because it's just 1K, right? So that's the middle term, plus 3J. Now for the last one, let's take it one step at a time. 2 times what gets us a positive 2? 1. And let's put plus 1, okay? And then how about J times what gets us J squared? J. And how about last but not least, K times what gets us K squared? K. So ladies and gentlemen, there it is. You factored it. Let's move on to the next one. Factor out the GCF right there. Okay, so again, you're going to look at all 3 terms. This term, this term, and this term. And you're going to think what's in common in each of the terms. And not only what's in common, you want to think what's the greatest value that's in common. In other words, yeah, 18 is divisible by 2, 12 is divisible by 2, 6 is divisible by 2. But you don't want to just stop there. 6 is the greatest common factor. Because this is divisible by 6, divisible by 6, divisible by 6. So let's do this. Let's put parentheses here. Let's put a negative 6 out. No, not negative 6. Let's keep it positive. 6 out there. Now, how about the R's? There's R to the third, there's R to the second, there's R to the second. How many R's could I pull out from all 3 of them at the same time? R squared. So it's 6R squared. And how about T's? Well, I have 2 T's here, 2 T's here, and 1 T over here. The greatest amount of T's I could pull out from all of them simultaneously would just be 1 T. So your GCF is 6R squared T. So what would be left on the inside? It's as easy as this. 6 times what gets you negative 18? Negative 3. And then how about R squared times what will get you R to the third? R, that's right. And then last but not least, T times what gets you a T squared? T. So your first term is really negative 3RT. The next one will be 6 times what gets you a plus 12? Plus 2, so put positive 2. Well, I shouldn't have changed colors there. Let me keep it blue. Plus 2. And then R squared times what will get you R squared? You don't have to worry about it because it's already R squared. And then T times what gets you a T squared? T. And for your last term, 6 times what gets you a negative 6? Negative 1. So put minus 1. And then R squared times what gets you an R squared? You don't have to worry about it because it's already R squared. And then T times what gets you a T? You don't have to worry about it because it's already a T. Ladies and gentlemen, that's your answer. There it is, rewritten a little nicer. Everybody please jot this down. And if I ask you to factor 2x to the third minus x squared plus 8x minus 4, always you're thinking about factoring out the GCF. So is there a 2 in common in all four terms? Is there a 2 in common in all four terms? No. We're talking about the coefficient, all right? So you have a 2 right here. Right here you have a negative 1. It's not a 2. So there is no 2 in common. There's not even a 4 in common or an 8. So you can't pull out a number. So maybe you could pull out x's. Is there x's in all four terms?
Yes.
What about this guy over here? No. So you can't even pull out an x either. So ladies and gentlemen, I want to get this to you right now. Always try to pull out the GCF first. But right here there's nothing in common. Nothing in common. All right? So there is no 2. If you think, oh, okay, here's a 2. There's a multiple of 2 in the 8. There's a multiple of 2 in the 4. But there is no multiple of 2 in the negative 1. Right? Okay, so good question. Could you really pull out a 2? No, you can't. Because there is no 2 right here. If there was an invisible 2, or if there were actually a 2 right there, then yeah, you could pull out a 2. But that 2 is not there. Okay? So this is what I'm about to do. I'm going to show you a new method. All right? It's called factoring by grouping. All right? So you guys could jot this down from the video at home. Hit pause, jot down these steps. You first want to make 2 groups. All right? Now, how am I going to make 2 groups? I'm simply going to rewrite it, but with some space. 2x to the third minus x squared space plus 8x minus 4. Everybody understand step 1? All I did was take the first 2 and the second 2 and split them and made some space in between them. That's step 1, nice and easy. Step 2, factor out the GCF from both groups. And you know what? Maybe instead of from both groups, it should be from each group. So factor out a GCF from each group. That is step 2. So let's do that. Let's look at the first group right here. And the first group says 2x to the third minus x. What could I pull out from that first group? What's in common in this first term and the second term? There's x's and there's x squared would be your GCF. So if you pull out an x squared from your first group, what would be left in there? 2x minus 1. You guys agree with that? Now how about the second group? What's in common in the second group? Over here, that one's easier because there's an 8, there's a 4. You could pull out what? 2, bless you. Okay, so let's pull out that positive 2. And what would be left if I pull out a positive 2? You know what? Pulling out a 2 is not the GCF. It's actually for the GCF. That's why it's important to always use the GCF. The greatest value to pull out would be 4. So what would be left on the inside if I pull out that 4? 2x minus 1. So that was the second step. Let's go back to the steps up here. Step 1 was make 2 groups. Step 2, factor out the GCF from each group. So in the first group, the GCF was x squared. In the second group, the GCF was 4. And now take a look at step 3. It says take a step back, factor out what's in common in both groups. So ladies and gentlemen, let's take a step back here. Here's my first group. Here's my second group. What's in common in both groups? The 2x minus 1. So I'm going to take the binomial 2x minus 1 and I'm going to pull it out of both groups. That's step 3. Ladies and gentlemen, let me show you. I'm going to pull out the 2x minus 1. 2x minus 1. I'm going to pull it. Whoops. I'm going to pull it out. And what's going to be left on the inside of my parentheses, this x squared. If I pull out the 2x minus 1, the x squared is going to be left. So I bring down x squared. If I pull out the 2x minus 1 right here, pull it out, what's going to be left? Just the plus 4. So once again, the third step okay, here I was. This is what I had. I had the first group, second group. I pulled out an x squared. I pull out a 4. That's step 2. Now step 3 is to take a step back and pull out what's in common in the first group and in the second group. Well, what do I have in the first group and in the second group that's identical? This red binomial, 2x minus 1. So what I want to do is I want to take this guy and I'm going to pull it out. I'm going to take this 2x minus 1 and this 2x minus 1 and I want to pull it out right here to the outside of these parentheses. 2x minus 1, 2x minus 1 comes out in the front. What's left? The x squared comes down, the plus 4 comes down. Why is there a blank spot here? Why is there a blank spot here? Because I took these out. They're not there anymore. So I left a blank spot on purpose so you could visually see that the binomial 2x minus 1 is missing in both of these areas. Right? Now on your answer, you don't want to write it like that with exaggerated parentheses. You want to write your answer with correct size parentheses, 2x minus 1, x squared plus 4. So ladies and gentlemen, this trick right here is called factoring by grouping. Factoring by grouping. So originally, when we looked at this factoring problem, we weren't able to factor it because there was nothing in common. But with this new method, factoring by grouping, we split the groups. We took these two binomials, that two, split them. We factored out the GCF from the first one. We factored out GCF from the second one. We took a step back and we realized, hey, there's a binomial in common in both groups. Pull that binomial out. What's left over? The x squared and the plus 4 is left over. There's my factored form. Now remember, factoring is a reverse distributive property, which means if I were to take this problem right here, and if I were to distribute, let me do that. Let me demonstrate. 2x times x squared, 2x to the third. How about 2x times 4? What's 2x times 4? Positive 8x. And how about negative 1 times x squared? That's negative 1x squared. And how about negative 1 times positive 4? That's negative 4. Ladies and gentlemen, this is our answer, which is the question that it came from, right? If I were to distribute, which I did, we actually get back to where we started. So as you can see, it is what we started with. The 2x to the third is right there. The positive 8x is right there. The negative 1x squared is right there. The negative 4 is right there. Okay, so here's the slide on factoring by grouping. We have this problem that's explained on the slide, but I like you to think of these steps. Step 1 is to make two groups. Step 2 is to factor out the GCF from each group. And step 3 is to take a step back, factor out what's in common in both groups. So if you follow that on this example right here, so you have two terms here, two terms there, make space between them. In the first group, you could pull out a 4r, that's what you'd have left. In the second group, you could pull out a 3, that's what you'd have left. Then you pull out both the q plus 2. I don't like the way the slide actually has this set up, because the q plus 2, I would put it out here in the front, and then the leftover 4r plus 3 would be what's left over. So we're going to go over factoring by grouping on the next video.